Let's have a look at how to geometrically approach the root of an equation by using Newton Raphson method. We have an equation f of x equal to 0 and we have to find the root. So basically we are looking for some number c such that when this c is plugged in the function, it gives us 0. So we will call c the root of equation f of x equal to 0. So we know our result from calculus that if there is a function f of x which is continuous on an interval such that f of a is, let's say, negative and f of b is positive, then there must exist some c belonging to the interval ab such that f of c will be 0, which tells us that c is the root of an equation f of x equal to 0. Let's say we have an equation f of x equal to 0 and we have to find its root geometrically by using the Newton Raphson method. Let's say f of x is continuous on this interval AB and f of a is negative and f of b is positive. Let's draw a graph based on this information that we have so far. Let's say this point is A and this point is B. Suppose this point B is denoted as x0. So in Newton Raphson method, we need an initial point. Since we already got an interval AB, so either of these two is going to be called an initial point. So you can take A as x0 as the initial point, but here I am taking B as x0 as the initial point. Since we know that f of x is continuous on the interval AB and f of a is negative and f of b is positive. So let's mark f of a, which is negative, somewhere here, and f of b, which is positive, somewhere here. Since we know that the function f of x is continuous on the interval AB, so this point, which has the coordinates a f of a, and this point, which has the coordinates b f of b, or it is the same point as x0 f of x0. So let's join these 2 points a f of a and b f of b because the graph in between a and b is continuous. So wherever this graph is cutting x-axis, that is our root. We will try to approach this root by drawing the tangent lines. Newton Raphson method is also called the method of tangents. So you approach this root by drawing the tangent lines. So x0 is the starting point, which is actually b. So we are calling b as x0 and x0 is being taken as the starting point. You can definitely take a as the starting point. So for the starting point b, which we are calling also x0, what we do is opposite to point b on the graph, we go up on the graph and the point here is b f of b. At this point, we draw a tangent line. So, for example, it is this point, B, f of B. So, here we draw a tangent line. So, tangent line is the line which touches the curve at one point. So, of course, it is extended both ways. Coming back to this shape, So we draw the tangent line at point B, f of b. So this tangent line touches the curve at point B, f of b, extend it downwards. So this tangent line cuts x-axis at a point. Let's call this point x1. So we started with point x0. Opposite to x0 on the graph, we have a point x0 f of x0 or b f of b. At this point, draw a tangent line. Tangent line is extended both ways, downward, upward. Keep on extending it towards the x-axis. Wherever on x-axis this tangent line cuts, you call it x1. So our initial point was x0. Now we have another point x1. Opposite to x1, go up on the graph. This point has the coordinates x1 f of x1. Now at this point x1 f of x1, draw a tangent line. When you draw the tangent line, extend it both ways. This is this tangent line and it cuts the x-axis at the point x2. Also this point is the root, means the graph is cutting x-axis at that point. So we have approached towards root. x2 is the root of equation f of x equal to 0. Let's have a look at this again. So we have this xy axis and we have points A and B on x-axis. Opposite to point A, we have a f of a, and for B, somewhere here we have b f of b. Let's say we have a continuous graph in between A and B. So we will join A f of A with B f of B. So we have joined A f of A with B f of B, and this is the root that we have to approach. So we will start with B as x0. So this point is x0 f of x0 or b f of b. So since we are starting with x0, so what we will do is we will go up on the graph opposite to point x0. We will reach here x0 f of x0. At point x0 f of x0, we will draw a tangent line which touches this curve at the point x0 f of x0. Tangent line is extended both ways, but we are just extending it down towards x-axis. Wherever this tangent line has cut, let's call it x1. Now after x0, we have a point x1. Opposite to x1, we will go up on the graph. We will reach here. It has the coordinates x1 f of x1. Now at this point x1 f of x1, draw a tangent line, extend it all the way to x-axis. Wherever it cuts, call it x2. Now opposite to x1, go up on the graph. You will reach at the point x2 f of x2. At this point x2 f of x2, draw a tangent line, extend it towards x-axis, and when you do that, you get this line, this one. So this tangent line that you drew at x2 f of x2, it cuts through the root, which we are calling x3. It is this point. So by drawing the tangent lines, we have approached towards the root. So we will say x3 is the root of the equation f of x equal to 0. Let's have a look at this graph. So I'm calling this curve as the graph. It is the graph of some function f of x, and wherever this graph cuts through x-axis, that x value is called the root. And in the above picture, we have tried to approach towards this root by drawing the tangent lines. Let's say you have another graph. This time it is something like this. So here we have two roots. One is this, where the graph is cutting x-axis at this point, and the graph is cutting at this point. Let's say this was the graph of some function f of x. So if we are calling this x value as a and this x value as b, so what this picture says, f at a is 0 and f at b is 0, means this equation f of x equal to 0 has two roots, that is at x equal to a and x equal to b. So this is how we approach towards the root by drawing the tangent lines.